Hello and welcome back to the Diaries of Space Explorers. I am your host, Gavin Tolometti, and in this episode, we're going to be speaking with Dr. Ali Bramson, an assistant professor and Mars research scientist at the University of Purdue. We get to learn the incredible journey of how Ali found her way to space by getting to view the surface of different planetary bodies through NASA internships and opportunities she managed to find as an undergraduate. Since then, she has been using NASA spacecraft missions to study the surface geology of Mars and other planetary bodies. And we also get to hear how she was able to develop soft skills that would not only be able to help us as a researcher, but to help her as a professor. Without further ado, let's get right into the episode.
My path has been like pretty linear, I guess, in terms of, I was one of those people who apparently at the age of like 4 or 5, I was going around being like, I want to be an astronaut, I love space. And that just stuck with me the whole time. I think a lot of us that are in space exploration and a lot of people that are not in space exploration are really captivated by space, even as like a kid. And that was certainly my case too, where I think like in preschool, we had maybe a solar system unit, and I think we did in 3rd grade as well. And, I got exposed to something about heard about space at some very young age and was just like, oh, that's so cool. I want to do that. And I was like, I want to be an astronaut. I want to be an astronaut. And, was an astronaut for Halloween every year. And
was it a particular astronaut each time or just a general astronaut?
No, just a general astronaut. And and when you express interest in something as a kid, then oftentimes you get that sort of stuff as presents and people kind of facilitate it. And so then I just kept getting more space stuff and kept just maintaining this obsession with space and becoming an astronaut to the point where all of my assignments growing up that I turned in school, I wrote my name as Ali Future Astronaut Bramson and signed it. People were like, oh, your middle name, what does FA stand for? And I was like, Future Astronaut, obviously. So yeah, it was just this obsession I had early on, and was fortunate enough that my parents sent me to space camp when I was a kid, and that was awesome. And I think at some point in high school, I realized that it wasn't necessarily becoming an astronaut that was my goal, but I really liked science, and I wanted to try to explain things in space. And so I pivoted there a little bit and was like, oh yeah, science. I always knew I loved science and stuff. But then I saw a lot of astronauts come from military backgrounds, and that being an astronaut doesn't necessarily mean that you're the one making discoveries about space. Being a scientist is what does that. And so I then, went to college and knew I wanted to major in some sort of science. And I went to the University of Wisconsin-Madison, which was just down the street from where I grew up. And they had a degree in astrophysics. And so I did astrophysics physics degree and got involved in undergraduate research that really helped me hone in on my research interest, because I realized in college, I had a little bit of a breakdown sort of midway through college where I was I honestly, I wasn't loving my classes. And I feel almost a little embarrassed to say that. And, but yeah, I felt really stupid a lot of the time. I felt I wasn't understanding, the topics were really hard. It was difficult. And I was am I even understanding everything well enough to go through this path? And I was one of the only women around, and I didn't have any like female professors in physics or astrophysics. And I just like, I was like, well, I've always wanted to do space, but like, what kind of, I don't know. So I was like, I need to find the type of space that just like motivates me so much that I can see myself like going to grad school. And so I got involved in some research, both on campus and through like summer internship programs that are available for undergraduates, and was really lucky that I was able to get involved in research in planetary science. And that's where I finally had that like moment of like, oh my God, this is what I've been training my whole life for. This is so cool. Like I get to like look at pretty pictures that NASA spacecraft are returning of other planets, and like use robots in space to try to look at, and like, so planets felt like the right sort of scale of things. Like I did a research project on nanoparticles, which was like really, really small, like 10 to the minus 9 meters. And then I did a project looking at galaxy clustering. So I've spanned like 30 orders of magnitude in size. And then finally, when I discovered planetary science as a field, I was like, okay, this is it. This is what I want to do. So like I said, I feel like it's been a linear path, all things considered. It was like, okay, I want to do space, go to college, do something in space, figure out what kind of space. But it certainly took me, a few years in undergrad to figure out like what that actually meant for a career, and what I was passionate enough about to like, commit to for a PhD and all of that.
Yeah, I feel like when we, especially in undergrad, when we think about space, only jobs we should think about is astronauts when we see them as kids, engineers that build probably the rockets and spacecraft, and maybe one or two lead scientists that sometimes appear in magazines or on TV. So we never really think about all the other opportunities that come with space. And you found that out in your undergrads when you looked at physics. When you're taking physics, you realized maybe this isn't it. Maybe I need to go back to space and find it. And you said planets were what you wanted to do after you broadened your horizons, looking at stuff that was very, very small at nanoscale and looking at galaxies. But that's when you realized, no, right in the middle, planets. It's a good size, not too small, but it's not ridiculously big like a galaxy. That's a bit intimidating.
Yeah.
So, and the viewers can't see this, but I have a feeling we know which planet it is, because I do see a globe of our neighboring red planet right behind you. So
yeah,
I want to guess that, is it Mars was the planet that you found yourself working with?
Yeah. So Mars is where I've done most of my research, and I didn't necessarily have like that figured out heading into grad school. I was like, I want to do planetary science. It felt really like down to earth, but at the same time otherworldly, like almost, by working with spacecraft data, like I feel like I get to be an astronaut without leaving the earth. It's like as close as we can get, right? Like we get to send these robots into space in our place and ask them like, hey, can you take this piece of data for me, and then get to analyze it. And so I think planetary science, and for me especially working with spacecraft missions like NASA missions, and using data that were collected on other planets, like is just perfect for me, because I feel like it's achieving everything that I wanted in, when I was a kid going around saying I wanted to be an astronaut, but like doing the science component of that, and like that I get to feel like I'm almost like on these other planets, like looking down, being like, okay, this is like a cool feature. Let's make sense of it. Like what is it like there? So yeah, most of my research has been on Mars, and we've got an amazing set of data on Mars from lots of different missions that have been there. So it's an exciting place to study because we've got so much data. But I've been also, I dabble in other planetary bodies as well, and more interested in the processes that shape the surfaces that we can see, rather than being like specific to one planet or the other. But yeah, my focus has been on like Mars ice.
Okay, so it was particularly the ice that got your attention. Was it was it like an immediate discovery, like ice on Mars is what I want to study, or is it more of a gradual discovery for you that you realize this is actually what I want to focus on Mars?
Yeah, I think it wasn't really that like ice on Mars is what like, drew me in. It was like that idea of working with spacecraft data. And so when I applied to grad schools, I knew I wanted to study surface processes and work with spacecraft data. Those were like the main two things. And then the first project that I started working on ended up being about Mars ice. And so from there, I was just captivated. But I mean, I'm captivated by like so many surface processes in the and working with different types of data set that our robots send back. So like I'm working on a project on what's called crypto mare on the moon. So like buried lava flows on the moon right now as well. So certainly I think ice on Mars is fascinating. It's like the bulk of what I've been researching. But yeah, I think surfaces across the whole solar system from a range of processes are fascinating.
Yeah, it's like looking at all these different images of Moon, Mars, and I think for me one of my favorites to look at is the surface of Pluto, because it's so unique, and a lot of people don't realize that our planet and Mars is not the only place where we can see stuff that's actively, what we believe to be actively ongoing, and just getting to see that you see all these similarities. It just shows how connected I think a lot of these planetary bodies actually are, in their own mysterious way that we still don't fully understand. But I think that's part of the fun, is trying to figure out why they sometimes look so similar. And you getting to look at missions, NASA missions, looking at all these images, you got to see that firsthand. And so when was it that you definitely knew that sending robots, looking at the data from spacecrafts and rovers was what you wanted to do?
Yeah, so that was an undergrad when I got involved in so then in the US and the National Science Foundation has what are called REU programs, so research experiences for undergraduates. Though there's analogous programs, and I think you did like one funded by the Lunar Planetary Institute, like a summer internship for like undergraduate research opportunities.
Yeah.
So yeah, there's a set of opportunities out there for undergrads to get involved in research. And so the two that I happened to do were these National Science Foundation ones. One was at Arecibo Observatory down in Puerto Rico, and the telescope recently collapsed the last few months. So that's been really heartbreaking. But I got to go down there the summer after my second year of college. I got into this REU program and was shooting radar beams at asteroids and trying to look at the signal that came back and figure out the shape of these small bodies in our solar system. And so from that, they sent me to a conference in planetary science where scientists get together and present their research, and everyone figures out what each other's working on, and you get the latest results and stay up to date on the sort of the pulse of what's going on in the field. And so there I saw the range of what was being worked on in planetary sciences as a field. And I was like, oh yeah, this is what I want to do. But even within planetary science, I was like, oh, like what exactly do I want to work on? And I came across another REU program the following summer that was at the SETI Institute, the Search for Extraterrestrial Intelligence. Its name is catchy. Everybody, thinks of SETI and like you're trying to find aliens. And but they had a summer intern project on looking for changes to the surfaces of Jupiter's moons in between the Galileo mission and when the New Horizons spacecraft flew by Jupiter on its way out to Pluto. I was like, oh, like Io is the most volcanically active place in the entire solar system, which I just find like amazing. Like there's active volcanoes spewing stuff out right now as we speak. And so I was comparing images from these two separate missions trying to look for changes that have occurred on Jupiter's moons on the surface, and like looking for new lava flows that could have erupted in between when these two robots flew by. And that's when I was like, okay, this is, yeah, done. Have it figured out. Like working with robots in space is just so cool. And I like having some observation that I'm trying to explain. And so, and the types of data, so I work with like camera images from these robots, and then also I do a lot of stuff with like radar. And the moon project that I mentioned I'm working on, like that uses Arecibo data. So it's fun that it's sort of come full circle in the last 10 years. And so, yeah, both of those undergrad research experiences, that they were so critically important for me getting to where I am and teaching me some basic skills and helping me just figure out like what I wanted to do for my career.
Yeah, those opportunities, I'm not gonna lie, sound one, extremely cool, and two, they were probably breathtaking when you got to look at all those images of the Jupiter's moons, especially Io, because that's actually my favorite planetary body in the
Nice.
solar system. Everyone thinks for me it's the moon just because I studied the moon, but it's like, no, the moon's cool, but there's another moon that's better because it's constantly as you said, spewing lava, and it's making Earth look very dry and inactive. So it's like, why? It's so small but so fiery, and you want to know exactly what makes it tick. And
Yeah.
I think these opportunities you got, I think, will be very handy for other undergraduates or even soon to be undergraduates that are maybe interested in space exploration. They should probably look for these opportunities, because I think getting hands-on experience is a lot better than just learning everything from class. You get to see what it's actually like to work with some of this credible data.
Yeah. Yeah. And like being a scientist, growing up and taking classes, you sort of learn about science from like the what is already known point of view of like, okay, here's this equation, now solve it with assuming these numbers. And it doesn't always, you don't fully appreciate what being a scientist actually is, where it's like, we are paving the way, trying to create completely new knowledge. It's different than the science we get in classes where we're being taught about what's already known. We're trying to apply that and figure out new things. It's not as simple as just being given an equation and given a couple numbers and being told what to plug into that equation and solving it and getting one right answer that, your teacher says like, yep, you did this right. It's, kind of going through the forest trying to figure out like, what is going on here? Am I right? Am I not? Like, and just trying to piece together the data and the evidence that supports a story. And yeah, so I think getting that experience of what it's actually like doing science, not just learning about science, is really important. And also seeing like, as scientists, we end up getting a pretty specialized knowledge base. And so when you think about space and you're reading about space, you might see like popular science articles about like everything from like galaxy clusters to black holes to planets to finding aliens to, it's like space encompasses a huge range of like subdisciplines and techniques. In planetary science, you can be a planetary scientist who approaches understanding planets from a physics point of view, a chemistry point of view, a biology point of view. It's a engineering, like it encompasses all of these disciplines of science that we traditionally think and brings them together. And so I think, yeah, getting like that hands-on experience can be really, really formative for figuring out like, okay, well, how do I like approaching problems? What kind of perspective do I want to bring? And what sort of narrow subset of all of science do I want to make my expertise?
Yeah, no, I definitely agree with that. I think getting all that experience opens your eyes a lot more to what it is you can be capable of and what's actually out there for you in the field of space. So, and this would be more of a direct question about those experiences. What would you say was the most memorable parts of getting to work on these projects? Like something that really stands out to you?
I think I'm trying to think if there's just like
It could be more than one as well, if there's many.
Yeah, I mean, I think, part of it was like seeing during those undergraduate experiences, like, oh, wait, this is something that I can do. Like, this is something like I could just work with NASA data. That's a career that I can do. And like this data is available for me to download and work with. It's not this like top secret thing or that all, it's like, first of all, that it's accessible, like all the data returned from NASA missions is put online for public use. And even the HiRISE camera on board the Mars Reconnaissance Orbiter, it takes public suggestions. So you can like make an account at the HiRISE website. It's called HiWish is the tool. And you can actually suggest where you want your images, where you want this NASA, robot to take an image for you. And those suggestions go into the same database as scientific suggestions as well. And we go through them and figure out, okay, where should we take images? But that it wasn't really like a one defining moment, but it was just like this buildup of realizing that this was something that I could be involved with. And it just all of a sudden felt a lot more accessible. And I think it's so cool. And I think people don't always realize that all this data is available for anyone, even if you're not a professional scientist. You can go download the images that scientists use for their work, and you can make them your desktop backgrounds. Or if you want to, go analyze data, you can access that. And so I think it was like that realization for me, which started in undergrad, when it was like, okay, go download data from the Galileo mission and the New Horizons mission. And I was like, what? I can just go download that? Like some top secret person doesn't have to like come in and give it to me on a hard drive. Like, it's like, oh, this is just on a website. Okay. So I think that was like a big turning point for me was that. And then starting when I got to grad school and was able to start getting involved in like the mission teams, that was another big moment for me, realizing again, like, oh, this is something that I can do and contribute to, and getting to go, visit other institutions. And with the Charade radar instrument that's on board the Mars Reconnaissance Orbiter, like getting to go to a meeting at the Italian Space Agency, who built this radar instrument that was supplied then to NASA to be put on the Mars Reconnaissance Orbiter, and being like, whoa, like 5-year-old me who wanted to be an astronaut would be like so excited to know that I'm just like hanging out at the Italian Space Agency, like as part of like a NASA mission science team right now.
Oh my God, that's actually so amazing. Like, what was it like going to the Italian Space Agency to see firsthand what it's like behind the scenes of a spacecraft instrument?
Yeah, I mean, I think for me, like that's one of the things that just like makes me so excited and is super rewarding is being involved in like missions and getting to like meet the PI and the principal investigator who's in charge, and just like interact with the team and be part of like requesting new data and analyzing data right when it comes back. And so yeah, certainly the times that I've gotten to like in the pre-COVID days when we were traveling, going to team meetings and getting to visit these other institutions, and going to like NASA Center, even other like space agencies. Like it's just, I don't know, it's so cool.
Yeah, I always think back that pre-COVID time, how much we took traveling for granted, where we could just hop on a plane and go anywhere. Now it seems like an entirely new hassle just to even think about ever flying again, because I can't even imagine what's going to go through my head the first time I probably step on a plane since
yeah.
March 2020.
Yeah, it's yeah, it's sort of weird how quickly, you know, things changed last year. And like I had so many different like meetings and stuff I was going to, that by the time the shutdown happened in like early March, I had already done so much like travel, like for work related things, that I already had like gold status for the year, just like 2.5 months in. And then it was like all of a sudden like, oh, we're not traveling at all anymore. You know, now I haven't traveled for almost a year. And like, it's sort of nice though, because I mean, it's not nice, but in a way that we've made things work with virtual meetings, and maybe it'll reduce the carbon footprint of the scientific community, because like these interactions that we all have in these team meetings and these conferences are so integral to, you know, staying up to date on the discoveries that people are making, and keeping everyone just up to date on and presenting your results and coming up with ideas. Like I didn't appreciate how much of science is like collaborative these days. And so, you know, I feel like a lot of that collaborative atmosphere has sort of taken a bit of a hit with COVID. But it is nice to see like, okay, other virtual things are coming along that can hopefully help bridge that. And maybe it'll mean that there isn't as much travel. Like travel isn't the restricting factor for these collaborations to still happen, I guess is what I'm trying to get at.
Yeah, I think what we have found out that even without getting to visit people in person or attend conferences, the internet and other means of virtually communicating has allowed not the same type of collaboration, but allowed us to find new ways to reach out and collaborate with, whether it's just to talk about space, or whether it's to maybe find your future boss or a future position at a school. I think we've been able to adapt quite quickly with the situation at hand.
Yeah, for sure. But I am finding now that like I'm starting to get to the point where I'm like, oh, I miss, you know, those in-person interactions. Yeah, I sort of had been taking for granted how much science like gets pushed forward at these meetings, when we are all just sort of stuck in the same place, talking through ideas. And that goes back again to like science really being where, as a scientist, we're at that boundary of new knowledge and trying to push it forward. And it's very different from, you know, just putting your head down in a textbook and trying to understand what's in the textbook and what's already known and solve some equation. It's really, I don't know, at least for me, like I'm a very social learner. So talking through things and bouncing ideas around and hearing from other people about their experiences and what they've learned from things is really helpful for me for like learning and doing my own science. And so, yeah, going to meetings and conferences, I'm realizing is like a big source of inspiration, I guess, for me and my science. So hopefully we'll be back to doing that soon.
I hope so as well, because I'm in the same kind of boat. I mean, I miss being able to sit in a room with a team. We all work together to figure out a solution or think of a solution to a problem. We're inspiring each other and about, as you said, bouncing ideas. I do really miss that, because that's usually how I like to thrive when it comes to my work. And doing it on your own is a different animal to tame altogether, because it's a lot of self-motivation and trying to figure things out. And if you get stumped, you need to find ways to figure it out. So
yeah, and like it's just having different people who just like come in with like different ways of thinking about it and different experiences and different knowledge, you know, that's where we can really push science forward and make really cool discoveries.
Yeah, because and getting to work in teams, you got to do that a lot from the sounds of it during your undergrad experiences, and from your grad school as well, because during the PhD you got to work a lot on the HiRISE team, the camera on the Mars Reconnaissance Orbiter.
Yeah. So, I mean, that was like such an awesome experience for me, getting to go to like the HiRISE camera team meetings, as well as the Charade meetings and getting to interact with like those teams and knowing the status of the instrument and how people were using it and what they were working on scientifically, I think was, it was such a big part of, I think what got me to where I am. And I think, it was just so much fun, like being in that collaborative team atmosphere. I really like working in that sort of situation.
Because to work in a team like that, was it part of your PhD, or did you find out the opportunity from someone at the department at the time?
Yeah, so that it factored into my decision on where to go to grad school because, so as I mentioned, I already knew that I really wanted to work with spacecraft data and be involved in missions. And I was like starting to get to get the realization that that was something that I could do. And so when I was trying to look into PhD programs and where to go, it was something that I was very much considering heavily in my decision. It was like, okay, what advisors could I work with, and that would open up opportunities like that. And so I did my PhD at the University of Arizona, and that's where the HiRISE camera is like operated out of. And the PI, again, principal investigator, that's like the person, like sort of the head person in charge of the instrument. He's located there, and my advisor was a member of the team. And so I knew that would, it was something that I guess I actively pursued when I was deciding to go to grad school, since I knew that was something that was such a big like motivator and scientific interest of mine, I guess.
Yeah, I think it definitely helps when you have your goals set and you find the institution that almost fits perfectly with what you're looking for. It makes things so much easier when you transition over. And it seems like you took everything you learned from HiRISE team, everything about planetary data, in particular Mars, and now you get to conduct your own research at Purdue University now. So that must have been quite a big transition, considering it happened during COVID as well. So you got to experience it differently than probably a lot of others when they finish up.
Yeah. So I just started a new job at Purdue, and am building my own research group here now, and have 2 PhD students of my own as of a few months ago. And I'm certainly trying to take lessons learned from my own experience. And now it's definitely an exciting time to try to now be like the PI of my own research group, and sort of be in charge of things and be a leader. It's sort of scary still, and I'm figuring it out. And it's definitely been an interesting time to have that transition happen. But it's definitely a really exciting time, and I feel super, super fortunate, and I'm excited to see what happens in this career, which can be like really exciting.
And I'm guessing, but being in the now more leadership role, you're getting to feel a little bit about what your supervisor probably felt when managing all of your 2 students.
Seeing it now from the other side is interesting, and definitely still learning. I think that's one thing that becoming a scientist and going to grad school and getting a PhD in a scientific field, you learn how to conduct a scientific study and publish that study, and get it out into the literature and the world. And there's not a lot of training in these other aspects of being a scientist. Like, we get a PhD and are planetary scientists, but there's not necessarily training in management and how to be a PI of an instrument or a mission or just a research team. And so I think, but yeah, that like the leadership and management ends up being an important part of science with how collaborative it is these days. And, you know, we wouldn't have data to work with without these big mission teams and thousands of engineers helping to make these, these missions fly and happen. And so, yeah, just seeing like how important teamwork is, you know, as a scientist these days, at least in, you know, in our field of science. And trying to then piece together the people skills to do that well. I think it would be awesome if training programs started incorporating more of those skills into the programs, because like, yeah, getting a PhD in planetary science, you end up becoming like a PI or a teacher or working at NASA. Like all the different job opportunities involve more skills than just literally publishing a scientific study by yourself.
Yeah, I'm hoping if any institutions or anyone who works at one's listening right now, they will try to push more for teamwork management and maybe development skills. I think could be something that could be implemented. Maybe not mandatory things to take, because it's bad enough that we already have our hands full when it comes to a lot of things in grad school. So, but if we offer more of these, maybe like a workshop, that might be quite handy for a lot of PhD students. Not even just in space, but I think any field, these types of skills are always handy to learn prior to having to learn them on the go when you take a lead role, because then it's less intimidating, I would imagine.
Yeah. Like, and you know, proposal writing too, and teaching, you know, we end up in a range of roles and positions as scientists. And so I know, like, I think more programs and more PIs are starting to include students in learning about the proposal writing process. So proposals are how we get money to do our science and fund it. We have to, propose to NASA, like, hey, NASA, fund this study. And that involves a lot of paperwork and documentation and coming up with a good idea and writing about that idea effectively. And, you know, all of those are important skills. Again, that like I never realized, I guess, growing up, or even only started to maybe appreciate a tiny bit in undergrad, what it actually meant. Like, what does being a scientist mean? And I thought like, oh, I don't like English class. And now I spend most of my time just writing and being a good writer is like super important. And I never realized that when I was a kid, being like, I want to be an astronaut, I want to be a scientist, I want to study space. Like, there's all these other skills that it requires.
Yeah, I feel like in science we need to include more non-science skill bases to make probably our professional development a lot easier and more manageable. I think focusing too much on the hardcore science really restricts what we're actually able to do once we leave the comfort of grad school, where we have supervision, we've got access to resources, but then when you're on your own, you realize, oh no, I wish I had learned all of this before I left, and now I have to do it on my own with less choices. So it's
I mean, it's certainly important to know, you know, learn the skills of like how to actually do the study, like the technical skills, but there's so much more than just that to learn. But yeah, I know, like I did a lot of community theater growing up. And like looking back on it, I was like, oh, you know, now that I realize, like I mentioned how early in 2020, like I was traveling a lot before the shutdown, between going to lots of different meetings, and at meetings, people are giving presentations. At conferences, you give a presentation up, you know, in front of an audience about saying, this is what I'm working on, these are my results. And you know, having a little bit of public speaking almost as like a kid in the you know, chorus, just like singing up on a stage when I was in middle school or whatever, you know, I never would have realized at the time, like I'm going to be using those skills as a scientist when I'm traveling multiple times a year to go talk to other scientists and present to them sometimes on a stage or in front of a podium. So there's just like, yeah, there's so many different skills that it takes to be a scientist.
Yeah. I think like your example is really good that getting to be in theater helped you with public speaking and just presenting in front of large crowds. I think a lot of people don't realize that just because something's not related to science doesn't mean it's not going to be useful for you later. And sometimes you can have fun at the same time, and you don't realize you're developing the skills that you actually need that could help you later on. So if anyone's in theater and you want to get into science, don't quit theater yet. Keep going because you'll be a phenomenal speaker at all the conferences.
No, I mean, when I talk to kids or like parents who are like, oh, I want to encourage my kid to go into science, and it's like, don't just sign them up for like science club. Like I think having a well-rounded extracurricular, if like I said, like I'm really glad that I participated in a range of experiences because they've all come into play somehow as a scientist in ways that I wouldn't have realized.
Yeah, I think for me, if I didn't have my like cooking and baking on my side, I'd probably go a little bit insane. It's something that helps a lot more than I probably give credit to. And I think it is good for everyone to take a little bit of it. Doesn't necessarily have to be the arts, but just something that's like completely away from what your research focus is on or career focus is on. I think it really helps.
Yeah, I played like competitive ultimate frisbee when I was a grad student. So I was traveling, going to tournaments around the country, and had practice multiple times a week. And I think it was helpful because it gave my brain a distraction, especially because science, is oftentimes trying to come up with like new ideas and stuff. If you can just like let your brains need breaks sometimes, and we need to just go off and be thinking about something else. And maybe that processing is happening in the background. But having, I think, hobbies and doing other things is important just for being human but also being good scientists.
Yeah, no, I completely agree. I think that's something I hope everyone listening takes away from this. So I want to move to one of my favorite parts of this podcast is the 3 questions that I ask my guests at the end. So I hope you're ready for almost like I wouldn't say quick fire, but something to spruce this up even more. So I want to start off with the first question, which is if there's a future mission being planned, let's just say unlimited funding, hypothetically, what planetary object would you want it to go visit?
Yeah, so I think, I don't know. First of all, it's just so hard to decide because all the planets are so cool. And, you mentioned Pluto earlier, and oh my gosh, Pluto is just like fascinating. And, we never even knew until we like sent the New Horizons spacecraft there and had these images, like just how like vibrant of a world it would be. And so I think that I would choose an ice giants mission, like to Uranus, for example. The ice giants are Uranus and Neptune, and we now know enough about them that they're being distinguished from the gas giants of Jupiter and Saturn. And there's only been like a single flyby of the Uranian system, and it was over like 30 years ago. And it took just a couple quick images of Uranus's moons, but it was like winter time, and so half of the planet or half the moons I think were like in shadow, and so basically we've never even seen like a whole half of the moons of Uranus. And just given how much we're like seeing all these like vibrant active processes going on in the outer solar system, like in the outer solar system moons and Pluto, like I just think I'm fascinated by like the satellites of the outer solar system planets and bummed by the lack of data out there. So I would love to see a mission go like out to Uranus and do a moon's tour and collect a lot of awesome data. I mean, even from the couple images we have, there's some fascinating surfaces that I just want to try to explain. Look so cool. And it's like, these aren't just like these old dead bodies that have just been bombarded with craters for all time. Like it's clear that, things have been happening and shaking them up. And, even like we were talking about earlier with Io being the most volcanically active place in the solar system, it gets its heat from sort of the friction of stretching and pulling by being around Jupiter and its interactions with the other moons. So we know that these places can have internal heat, and that then can also create huge subsurface oceans like on Europa. And then, Titan has this huge atmosphere and like hydrocarbon lakes. I mean, I don't know. It just is one of those things where it almost sounds like it's out of like sci-fi, right? And so I think the lack of data at the ice giants and the ice giant moons, given my bias towards being interested in surface processes, we need a mission there.
No, I agree. It's been I think some missions have always been proposed to go out there, but they always get shut down because I think it's the big question. They don't get the attention I think they deserve most of the time. Everyone thinks like, we know what Uranus and Neptune are there. They'll still be there in some years' time. It's like, but we need a bit more information. Like we used to think Pluto I think we thought it was like a very blue dot, and then we realized actually it's a brownish red rust color. And we didn't know that until they finally sent New Horizons to take better images of it. So we could be shocked if we sent something to Uranus and realized actually this is not what we thought it was. It's completely different.
There's like convecting nitrogen ice like glaciers on Pluto. Like what? That's so cool. So who knows what we would find in the ice giant system. And I think there's momentum that's been growing from a lot of the community that's like, it's time. It's time to go to the ice giant.
It's definitely time. I think that should be in a white paper maybe for NASA, like the rise to the ice giants.
Oh yeah, there's definitely some white papers on it. So I think there's momentum growing, and certainly there were white papers that were submitted to this like decadal survey, which is helping prioritize the next 10 years of the planetary science community's priorities. And so yeah, fingers crossed, but definitely people are out there pushing for it. But yeah, it's time.
I think it is time. So I now want to move into the incredible awesomeness that is space, to the benefits that we have gotten from space ever since the Apollo era. And so I wanted to ask you, what is your favorite spin-off technology?
Oh, that's another one where I just can't decide, but you're making me. So this one, I mean, it's hard because I feel like, the technologies that have come out of space exploration being a thing and being funded, like it just permeates through our society in so many different ways that I think, we don't always realize, and we don't realize how what we're all working on now and what things are being developed now. We don't even know how they're going to end up turning into the spin-off technology of tomorrow. And so, I mean, I don't know if I can decide. I mean, like I think LASIK, the like eye surgery, is a spin-off from a laser technology that like NASA was developing, if I remember correctly. And so that's all. I mean, I had LASIK and I love it. And I am so appreciative to not have to wear glasses and contacts anymore. And it makes playing sports so much easier. So, I mean, I also I'm really bad at navigation and getting from point A to point B, and basically have like GPS on my phone at all times. So I also really like GPS and the fact that we have cell phones and they have like awesome cameras in them. And like, it's hard to even like pinpoint one, because like so many things that went into all of these things are spin-offs like in and of themselves. And Yeah, I can't decide. I mean, I guess like from a yeah, GPS and LASIK maybe because I use them literally every day. And it helps me not get lost. But I think it's also like it's a good reminder too of like how, when we're investing in space exploration, like it's not just like money going into a rocket that's going into space. Like that money is developing technologies, it's paying engineers, it's paying scientists, it's paying those people to buy equipment, it's paying industry partners. Like that money is staying and being spent here on the ground to buy screws from the hardware store to build something. And that space exploration and the money we invest in it is really like that money is staying in our economy. We're not literally shooting dollar bills into space. Like, and so, and we don't know how that money investment necessarily turns into the technology of tomorrow, but we know and have data that show like that it does. And we have all these different things to show for it, from our phones to, how my eyes work these days, to me not getting lost, just trying to remember where the target is in my new hometown. So
Yeah, I think my favorite that I learned recently would be the cameras in our phones. Since before, like during Apollo, we used film most of the time. It wasn't a chip, but then thanks to new satellite imagery, we've been able to miniaturize into these tiny little cameras on our phones. So that's why I kind of like thinking like, so you're telling me that selfies came from space? If you think about it, so it's a good way, a good selling point. So every time you take a selfie, just remember it's because someone we sent a spacecraft into space with a camera and we miniaturized it.
Yeah, for sure. I remember I was once debating getting like a fancy big camera to take fancy, photographs on vacation or whatever. And I remember someone once told me like the best camera you have is the one that you have on you. And I still remember that. I can't remember who told me that, but I was like, oh, it's so true. Like if I'm going, half the time I don't want to drag, like me personally, I don't want to drag a big heavy camera with me. And so chances are I might leave it at home, but I'm going to have my phone with me. And so the best camera is the one that I always have with me. And that's the one that's in my phone and literally sitting in my hand or my pocket or right next to me 24/7, as is probably the case for a lot of us.
Yeah, I think nowadays when we think about why do I need a camera, my iPhone has much better pixel resolution than anything I could buy from the store, unless you want to invest in those few $1,000 lenses, which you then have to keep locked up in a tight little soft bag, or else one little scratch is like, well, it's ruined.
Yeah, I'm not willing to commit to that. So phone camera for me. And then it automatically just like uploads itself to my Dropbox. So then I have access to all my photos ever, which I think cloud storage and cloud computing, I think that's another spin-off technology. So it's just, like I said, it's
endless when we think about it.
Yeah, it's spin-off technologies all the way down.
Yeah. And so for our final question, since this is the Diaries of Space Explorers, I wanted to ask you, who is your favorite space explorer?
Sally Ride is a huge inspiration to me. She's my favorite space explorer. Like I said, I was obsessed with like being an astronaut when I was a kid. And so like having her as a role model, as like the first American woman in space. And I think actually the pivot point for me realizing that it was like I wanted to be a scientist and trying to figure out how to actually achieve that was looking more into her background and seeing here's a scientist that became an astronaut and she got her degrees in physics, and that encouraged me to be like, okay, I know that a background in physics can help me, it helped Sally Ride become an astronaut. So yeah, I think Sally Ride is just an amazing role model. And so yeah, she's my favorite.
So with those similarities in your like backgrounds getting to where you are, do you think you would still consider being an astronaut?
Yeah, so I applied in this most recent round, just for like, I don't know, to tell 5-year-old me like, you have the qualifications to like apply to be an astronaut. But like I think it would be super cool. But like I said, I think the job that I have, being able to work with spacecraft data, like, is just so cool that I think it's still true that, like, I don't need to become an astronaut. That's not like my sole driver. And yeah, I would love to be an astronaut, but I also love my current career path. So
No, I think the career path you have is spectacular, and I think you're on a good start to getting towards being an astronaut in the future, maybe making 5-year-old you very proud.
Yeah. Yeah, I think 5-year-old me would be just like knowing that I get to like look at a picture that came back from a robot in space. I'd be like, oh, this is great. This is like, yay, I did it.
No, but I do wish you the best of seeing how far, and maybe going down the astronaut application route. Because I mean, you never know. I think you probably have a very good chance of getting down.
Yeah, they probably want people that are like more in shape than me, though. I haven't played Frisbee now in a while. I took a break, and then the pandemic. A lot of the questions were like trying to get at like how physically fit is this person. I was like, I might not be what, but I don't know. And like I am pivoting. Like I would love to become like an instrument or mission PI someday. That's definitely the route that I would love to get on, and I'm hoping to achieve in my career. So yeah, we'll see. I don't know. I'm excited to see what happens.
Yeah, I think it's going to be a big, bright future for you right now. Even with the pandemic, once this is going to be finally over, hopefully in a few months or so after the summer, we can finally get back to some sort of normality.
Yeah, I hope so.
Yeah. So, Dr. Ali Bramson, I'd like to thank you for coming on the show and telling everyone about your journey. I think you've provided a lot of great insights into how space data can really inspire someone to get into space exploration, and also showing that if you're in theater, don't quit. Keep going, because you don't realize how useful it's going to be for public speaking in the future.
For sure. Yeah, work on all those skills.
All right. Thank you very much for coming on.
Yeah, thanks for having me.
Thank you for listening to the Diaries of Space Explorers, where we have been speaking with Dr. Ali Bramson, Mars research scientist, assistant professor, and ultimate Frisbee enthusiast. If you'd like to learn more about Ali's work, you can find her on Twitter at Ali Bramson. I have been your host, Gavin Tolometti, and if you'd like to learn more about the show, you can follow us on Twitter at Diaries of Space or on Instagram at Diaries of Space Explorers. You can also email us at thediariespaceexplorers@gmail.com. Thank you for listening, and see you all next time.